Quantum mechanics is quite popular. We've heard it being used in many ways, such as in TV series, sci-fi movie, and even in our daily life conversations, because saying quantum in front of any words makes it sound cooler and better. Like bacon, quantum cheeseburger. But what exactly is quantum mechanics all about? Although it may sound difficult, the key ideas behind quantum mechanics are not hard to understand. First of all, what is quantum? Quantum, which sounds very similar to quantity, is the smallest quantity of energy you can have. Similar to how we say atom is the smallest thing that make up other matter, quantum is the smallest energy particle that make up other energy that you cannot divide any smaller.
No.
So quantum mechanics is the physics of very, very tiny things, what they are and how they behave. Knowing that, the first key idea of quantum mechanics is everything is quantized, not continuous, meaning everything is some multiple of the smallest unit called quantum. To visualize this, we can walk down a staircase. Notice that you can only move one step, two steps, and three steps at a time, but not half step or fourth a step. A half step wouldn't work because stairs are quantized. Since the smallest unit of stairs is a step, you can only be on the multiple of the single steps such as 2, 3, and 4, but not half a step because it's not multiple of a step. It's same for everything, such as energy, that every energy is just a multiple of the smallest fundamental unit of energy, which is quantum. The second idea of quantum mechanics says that everything is both wave and particle. Now, how do we show this is true? We know light, which carries energy, behaves as wave in many ways, such as reflection. So, we just need to show that light behaves as particles. Proving this gave Einstein a Nobel Prize, which he proved by using photoelectric effect. Photoelectric effect is when you shine light on certain metal, it pops some electrons out. Einstein noticed that this only occurred for light such as UV light, but never for visible light, no matter how bright and intense the light was. Only viewing light as particle could explain this. As energy is quantized, electrons have set their minimum requirements for energy to accept to jump to the next level. The individual light energy particle for visible lights did not meet those requirements. So no matter how many they were, meaning how bright they would not pop electrons out. On the other hand, UV light's light particle had enough energy, so just a single light particle, which would be a very dim light, would be accepted by electrons, make them be excited, and bounce out. Light as wave predicted that the intensity of light should pop them out, but it didn't. The number of dropout electrons depended on the energy carried by the small light particle called photon. Light acted both as wave and particle, and this is called wave-particle duality. These two core ideas tell a lot about our known universe. The idea that matter can also behave like a wave tells us that matters actually fluctuate like a wave. Heavier objects fluctuate less, and lighter objects such as electron fluctuate more. So for an electron, after you blink your eyes, electron will be in a different place than it was before. But it doesn't mean it is suddenly gone. It is still somewhere in this area. We just cannot pinpoint where it exactly is. So the only way to figure out where it is by guessing. It is most likely that an electron will be around this area. So we say we have a high chance of seeing an electron here, but low chance of seeing it in other areas. Probability dictates our world. This is what quantum mechanics is trying to tell us. Quantum mechanics is a bunch of mystery. We still do not know why matter behaves like that, or why something even happens. We cannot even tell where we are. Only probability can tell us where we are. You may feel powerless, but think about it this way. The fact that you're born and you're breathing right now is due to the small particles that are all based on probability that diligently moves around in your body to form you. You are still here watching this video, learning about quantum mechanics. You, by living, are playing a game of probability. Your life, your memories, are an elaborate collection of millions and billions of such probabilities. So, congrats to you for being so lucky, or quantum lucky.